Hey everyone, in this video let's know about how to find out the number of microstates or degeneracy. Microstates is also called as degeneracy. Let's find out it for the questions in which electronic configurations is given and for the term symbol is given. If the question contains electronic configuration, we can find out the number of microstates, and if the question contains term symbols, then also we can calculate the number of microstates or degeneracy. This type of questions asking number of microstates or degeneracy is common in net or gate exam. Let's discuss now. At first, let's know the meaning of microstates. Take example of P2. If I take P2, it is written in this type, or else it can be written in this form also, and it can be written in this form also. Clearly, number of arrangements which are possible, number of arrangements of electrons which are possible in an orbital is called as microstate or degeneracy. This is about the meaning of microstates, but in the examination we cannot write this type of arrangements, so that's why there is a formula. Number of microstates or degeneracy is equal to n factorial divided by r factorial into n minus r factorial. Let's take the example of P2. Here n means maximum number of electrons which can be occupied in an orbital. So for S it is 2, P for 6 for P, 10 for D and 14 for F. R means number of electrons given. Here number of electrons given is 2 in the example. Therefore, number of microstates for P2 is equals to 6 factorial divided by 2 factorial into 6 minus 2 factorial is equal to 6 factorial divided by 2 factorial. This can be written as 4 factorial. 6 minus 2, 4 factorial. 6 factorial can be written as 6 into 5 into 4 factorial divided by 2 factorial, 4 factorial. 4 factorial, 4 factorial cancel. 2 factorial means 2 into 1. 2 ones are 2 3s are 15 number of microstates are possible in P2, or 15 number of degeneracy. Now let's consider this one, P1 D1. P1 D1. P orbital, write down the P orbital, write down the D orbital. 5 D orbitals and 3 P orbitals. 1 electron present in P orbital, 1 electron present in D orbital. Now write the formula. N factorial divided by n factorial into n minus r factorial. No, not that formula. N factorial divided by r factorial into n minus r factorial. So here r factorial into n minus r factorial. Here put into mark because here into is there. So write down same formula for for d orbital also. Here there are n means what? N means maximum number of electrons which can be occupied in an orbital. For p orbital it is 6 factorial divided by r means 1 electron. So 1 factorial into 6 minus 1 factorial. Here maximum number of electrons which can be occupied in d orbital is 10 electrons. So 10 factorial divided by r factorial means 1 factorial, 10 minus 1 factorial. So 6 factorial divided by 1 factor means 1, 5 minus 1, 6 minus 1, 5 factorial into 10 factorial divided by 9 factorial. 6 factorial can be written as 6 into 5 factorial divided by 5 factorial into 10 into 9 factorial divided by 9 factorial. 9 factorial, 9 factorial, 5 factorial, 5 factorial cancel. 6 into 10, it is 60. 60 number of microstates or number of degeneracy are possible for P1 D1. This is how the number of microstates or degeneracy is calculated for the P1 D1, that is if electronic configuration is given. Let's now consider this one, P1 P1. P1 P1. Number of orbitals are 3 and 3. Number of electrons present is 1 1. Let's take the formula now. into n factorial divided by r factorial into n minus r factorial. Maximum number of electrons are 6 divided by 1 factorial into 6 minus 1 factorial into 6 number of electrons maximum which can be occupied in p orbital divided by 1 electron 6 minus 1 electron. 6 factorial by 1 factorial into 5 factorial into 6 factorial by 5 factorial. 6 into 5 factorial divided by 5 factorial. 6 factorial 6 into 5 factorial by 5 factorial. So 6 6 are 36 number of microstates or degeneracy is possible for p1 orbital. Now let's discuss for s1 p1. For s1 p1, for s orbital number of electron is 2 possibility and orbital is 1, and for p it is 3 number of orbitals. So I will just not write the formulae. Let's directly simplify. Number of maximum number of electrons which can be possible in s orbital is 2, that is 2 factorial divided by 1 electron is present, 1 factorial into 2 minus 1 factorial. For p orbital maximum number of electrons which can be occupied is 6, that is 6 factorial divided by 1 electron is present, so 1 factorial into 6 minus 1 factorial. We know that 6 factorial by 5 factorial is 6. So directly write here 6 and then 2 factorial divided by 1 factorial, that is 2 into 1 2, that is 12. 12 number of electrons, 12 number of microstates or degeneracy is possible for s1 p1 orbital. Now let's discuss how to calculate number of microstates if term symbol is given.